Today I will show you how the Quartic Process Analytical Technologies, or PAT application, can be used to generate real-time and predictive quality values that can then be used to make real-time process adjustments to manufacture a more consistent, higher quality product. We do this by first connecting into our data sources, spectral probes and tags, along with offline lab results, and use that historical data to build machine learning models to produce real-time quality results. We can store those results as a soft sensor in the Quartic platform and also send them to a dashboard or an HMI screen for user consumption. Then we can move into predictive modeling, where we can create a predictive quality trajectory for the full duration of a batch, as well as a soft tag for the actual predictive quality values, which we can then compare against the expected ideal profile. This enables us to make proactive adjustments to our operations and reduce the dependency and the time spent waiting for lab results. So with that quick overview, let's go into the application itself, and I can show you how we can train some of these models. We'll start by connecting into our data sources to pull in both the spectral and lab-based samples that we'll use to train the model. So here on the left, we have the actual spectral wavelengths. Each one of these colored lines is an individual sample. Then on the right, we have the corresponding discrete lab samples coming in for our concentration. So using this wavelength and lab data, we can train models to take a real-time wavelength sample and calculate a real-time concentration value based off that. This gives us real-time feedback on our batch results so we can adjust and correct our process in real time rather than needing to wait hours or days for lab results. So to do this, first we can select what wavelengths we want to use. So if there's a particular wavelength set that's more relevant to train a model for a given quality attribute, we can narrow in on just those ranges. This is where some process expertise might be useful. So I'll keep these particular ranges for my selection. And then I'll move on to the next step, where I'm able to apply some pre-processing filters to my spectral data using some of the most common algorithms. And the results of this filtering will then feed into my model. In terms of the model output, because these data are discrete values, I can choose how I want to interpolate between them. And then I also have the option of what types of machine learning models I want to create. Do I want to stick to just linear, or do I want to enable higher order models as well? Once I make these selections, I'll move on to the next step, where I'll go through and create a model for my concentration soft sensor so I can see that in real time. And I'll also create a predicted concentration profile so I can see what my concentration should look like over the full batch duration, similar to a golden batch profile. Then I can trend previous or current batch runs relative to this profile. So this was a past batch run, and for a current one that's running, I could see not only how it's running in real time, but also that trajectory out into the future. And if I start seeing a deviation like I see here, moving away from this expected profile, that's where I can send out a notification or track this as an event within the Quartic platform. To see a little bit more about how this can be applied, I'll go back to my slides and show you a customer use case where we had a continuous reactor and we were adjusting the flow rate set points, intentionally introducing disturbances to see how that would impact our concentration. So the gold line, this is the flow rate as it should be to achieve our ideal concentration. That's right in line with the expected concentration profile in blue. Then we tried adjusting the flow rate either down to 0 in purple or increasing it in green, and we're able to see how that would lead to different concentration trajectories in green and purple respectively. In this case, we are also monitoring an overall batch health score, so we can see how this change in concentration also impacts the overall product health score, going from 84% if we followed the recipe down to either 68 or 49% based on those flow rate adjustments. And again, we were able to see that impact on the final product quality in real time while the batch was still running. So hopefully this gives you a quick idea of Quartic's PAT application capabilities, how it can be applied, how you can easily train up these models without writing any code. This application is ready to go off the shelf and also has configuration options to tailor it to your specific process and your needs. If you have any questions or would like to learn more, please reach out to us here at Quartic, and thanks for watching.